Now let's take the double ordinate which we have discussed in the previous session and find the endpoints or extremities or the coordinates of double ordinate. For example, I take a parabola y square equal to 4ax in its standard form. Then let's see what are the extremities of the double ordinate. So we know that the double ordinate is a line which is passing through any point on the parabola and perpendicular to the axis. Therefore, if I just have the diagram with this being x-axis and this being y-axis and this being origin, then the parabola which is in this form for y square equal to 4ax has, say, a point P through which I draw a perpendicular to the axis of the parabola, which is this. Then let me see what are the extremities or the coordinates of P and P dash of the double ordinate. So this being the double ordinate, I have y square equal to 4ax. That implies y equals plus or minus root of 4ax. If I just simplify this with taking root on the right hand side. Now this on further simplification gives y equals plus or minus root 4, which is 2 of root ax. So I have two coordinates out here, one given by x and y, that is 2 root ax, and there's another coordinate given by the minus sign, that is x comma negative 2 times root of ax. Is how we get the two coordinates. Therefore, one of them is represented by P and the other is represented by P dash. Now this being in the first quadrant is represented with P because both x and y are positive in the first quadrant. X is positive and y is negative, and hence this lies in the fourth quadrant, as can be seen here. Therefore, the coordinates of P are x 2 root ax, and the coordinates of P dash are x and minus 2 root ax are the extremities or the endpoints of the double ordinate PP dash. That's how we understand the coordinates of double ordinate connected with the parabola y square equals 4ax. Length of latus rectum. So we have discussed about latus rectum to be a line which passes through the focus and which is perpendicular to the axis. Say for example, I take the parabola y square equal to 4ax, and we know that this parabola is in the shape of x-axis and y-axis, and the parabola which passes in this form. Now we know that the focus, the vertex is here and the focus is somewhere here, and we know that the coordinates of the focus are a comma 0 and the coordinates of the vertex are origin because the vertex is the origin itself. Now with this focus we define the latus rectum, which defines that any line which passes through the focus and which is perpendicular to the axis is nothing but the latus rectum. Now let me take the point of intersection of the latus rectum and the parabola as L and L dash. Therefore, the extremities or the endpoints of the latus rectum are L and L dash, where L dash represents the latus rectum and this represents the axis of the parabola. So with this we understand that the distance from V to S is A because the focus is with coordinates a comma 0, that is the distance from V to S along x-axis is A. So therefore the coordinates of L would be A, and my y coordinate, which I don't know, I'll take it as L, some L. Now since my x coordinate is same even here, my x coordinate is A, and let me take my y coordinate as minus L because this is equally at same distance, or this is equal to this, and therefore this being L, this would be minus L geometrically with identifying of the distances. Now once we know that L is A comma L, then let's see how we can find L. Now the question out here is to find L. So to find L, I use the parabolic equation y square equal to 4ax, that is L lies on y square equal to 4ax, that implies the coordinates of L, which are A and L, in place of x and y, are substituted in the parabola y square equal to 4ax. Therefore, L belongs to this implies my y coordinate of L, which is L, that is L square, is equal to 4a times of x, my x coordinate being A, comes out to be A out here. Now this on simplification gives 4a square, that implies L is root of 4a square. L is plus or minus 2a is how we get it. Now therefore, in place of L, I have two coordinates. One is plus 2a and the other is minus 2a, where 2a, assuming that a is greater than 0, my 2a would be the coordinate in the first quadrant and minus 2a would be the coordinate in the fourth quadrant, is how we get this. So therefore, I get this coordinates to be a comma minus 2a, and this is a comma 2a, is how we get the two coordinates of L and L dash. So a comma 2a and a comma minus 2a are the endpoints of the lattice rectum. That is, if I want to find the length of lattice rectum, I just find the distance from L to L dash. So let's see what would be the length of lattice rectum when we derive for its respective formula. So continued, let's find the length of lattice rectum. Now as we have found the coordinates of L and L dash, L being equal to a comma 2a and L dash being equal to a comma minus 2a, therefore the length of lattice rectum being equal to L dash is nothing but the distance from L to L dash, which we get by taking this as a and this as 2a, and this being also distance 2a. Therefore L dash is, if I take this with say m, then this is Lm plus ml dash. Therefore, as you see in the diagram, L dash can be written as Lm plus ml dash, which on further simplification gives Lm, which is clearly 2a, and Lm dash ml dash also, which is 2a. Therefore this reduces to 2a plus 2a, as can be seen in the diagram. That is nothing but 2a plus 2a is 4a, which I get as length of lattice rectum. Therefore length of lattice rectum is 4a units, is how we understand the concept of length of lattice rectum, which we are going to find using the geometrical properties and the equation of the parabola y square equal to 4ax. Length of lattice rectum is equal to 4a units. Significance of lattice rectum. Now that we have discussed about lattice rectum and its length, now let's see what is its importance in defining the parabola. Now as we see, the equation of the parabola is given in standard form as y square equal to 4ax. It is very essential that the value of a is to be known. So until and unless we know the value of a, we cannot define the entire parabola. So to understand the standard form of a parabola, it is very essential that we know the value of a, and the lattice rectum helps us in identifying the value of a. Let's see how. If suppose I know the value of A from the lattice rectum, say for example, this is x-axis, this is y-axis, and this is axis of the parabola. Now suppose I know the lattice rectum length out here. If I know the length of lattice rectum, I can know the endpoints, because if I know, say, value of A is 2, or the length of lattice rectum is 8 units, then clearly I can find the value of A from this, because L dash equal to 8 units implies my length of lattice rectum, which is 4A, gives me 8. That implies A is equal to 2, is how I identify the value of A using the length of lattice rectum. This, for example, here, length of lattice rectum is 8 units, gives me A equal to 2. Now this A equal to 2 will define the entire parabola. That is, we know that the coordinates of L and L dash are A comma 2A, and this with L dash are A comma minus 2A. Therefore, I can know the endpoints with just knowing the value of A. So A equal to 2, say for example, gives me the coordinates of L as 2 comma 2 times of 2, which is 4, and here this gives 2 comma minus 4, is how we get the endpoints. And we know the focus because it is exactly the focus with coordinates A comma 0, which we get here. That is, the focus is defined with A comma 0, and A being 2 defines 2 comma 0. This gives us an idea that the focus is 2 units from origin, is how we understand that the vertex, which is 0 comma 0, is exactly 2 units from the focus, or the focus is 2 units from the vertex. So we know L, we know L dash, we know that a parabola joins vertex with lattice rectum, and this with this. And if suppose I would like to find the directrix of this, then we know that the equation of the directrix is given by x plus 2 equal to 0. That is, x plus A equal to 0, which gives x plus 2 equal to 0. Is how we get the directrix, the focus, the vertex, the endpoints of the lattice rectum, and etc. Is how we can define the entire parabola by just knowing the information of length of lattice rectum. And what is the equation of this parabola? If suppose I assume this to be y square equals 4ax, 4 times a, which is 2 of x, that implies y square equals 8x is the equation of this parabola, is how we construct. So the significance of the lattice rectum is to identify the value of A, to identify the standard equation of the parabola, and to identify the entire shape and size of the parabola, as can be seen here with this example. A is 2, this is the parabola with the equation y square equal to 8x. Now let's see the various forms of expressing the parabola. So we have already visited the session. Now to start with, continuing with the previous session of discussing on transform the equations of parabola, we have 4 types of transformations which we identify in case of the parabola. So initially, if I have y minus k whole square equals 4a of x minus h, assuming a is greater than 0, then let's see how we can easily remember the formulae for this parabola. That is, if I want to remember the focus, the vertex, the directrix, or any other lattice rectum, endpoints, etc. for this kind of parabola, let's see how we can use the shortcut or easy method of remembrance. So for example, I take this transformed equation. Clearly I identify that this is in the form of, assuming this as capital Y and assuming this as capital X, this reduces to y square equal to 4ax, is how we get the equation of parabola. So the transformed equation, when I compare with this, we clearly know that this is the standard form of parabola y square equal to 4ax, where each of the parabola will have the shape like this, and the focus would be a0, the vertex would be 0, 0, and etc. and etc. So my directrix would be x plus a equal to 0, and my axis equation will be y equal to 0, is how we get. Now, because I have taken the x coordinate as capital X and my y coordinate as capital Y, then we understand that x is referred with x minus h and y is referred with y minus k, is how we understand the equations of the parabola in transformed form. So taking this as capital X implies x is x minus h and y is y minus k, capital Y, small y, capital X and small x. So with this we define the whole of the focus, the directrix, the vertex, the endpoints of lattice, rectum, etc. So we have L dash, which is a to a and a minus 2a. So let's see how we can define for this. Coming to the vertex. My vertex is generally denoted by 0, 0. That implies my x coordinate is 0 and my y coordinate is 0, is how I understand for the vertex. But my x coordinate is x minus h, therefore my capital X is replaced with x minus h equal to 0, and my capital Y, which is y minus k, is replaced with 0. That implies x is h and y is k. So therefore this makes me understand that the new vertex is h comma k, because my x coordinate is this and my y coordinate is this for capital X, and therefore this transforms to the new vertex. If I take this as equation 1, therefore vertex v dash of equation 1 is given by h comma k, is how I understand the vertex. It's easy. Just substitute for capital X and capital Y and take the original vertex and replace with 0, and you get the vertex of the required equation. So vertex is h comma k. Similarly, let's find the focus of the equation 1. Focus. Let's see how we find the focus in the similar manner. Now, as we take the original equation, y square equal to 4ax has the focus as a comma 0. So on this original equation taken in standard form of capital X and capital Y, my focus is a0, implies my x coordinate is a and my y coordinate is 0. That implies my x coordinate I assume as a and my y coordinate I assume as 0 in order to find the focus respectively. But my capital X is x minus h, which is a, and my capital Y, which is 0, is nothing but y minus k equal to 0. That implies I get my small x as h plus a and my y is equal to k. Therefore, my x coordinate and y coordinate replaced with x coordinate is h plus a and my y coordinate is k, is the focus. Therefore, focus S dash of equation 1 is h plus a comma k. So this is how we generate each of the vertex, focus, directrix, latus, rectum, etc. using the simple technique of capital X and capital Y. We need not by heart each of the formulae, but if we know the formulae for the standard parabolas, we can easily construct for the transformed equation. Now let's see how we can get the endpoints of the lattice rectum using this. So endpoints of lattice rectum. Now we know that the endpoints of latus rectum for the standard equation y square equal to 4ax are a 2a and a minus 2a. So therefore, L being a 2a implies my x is a and my y is 2a. That implies x minus h is a and my y minus k is 2a. And then we find x and y. That implies x is a plus h and my y is 2a plus k. Therefore, L of equation 1, that is when I take this in transform form, is nothing but a plus h 2a plus k is how we get the coordinates of L. And let's see how we get the coordinates of L dash in a similar manner. If I take this as minus 2a, L dash of equation 1, the only difference is that this reduces to minus 2a, so x coordinate remains same, and in place of a they get minus 2a plus h plus k. This is how we get the endpoints of latus rectum. L is this and L dash is this for transformed equation 1. And of course, length of latus rectum does not change when the whole parabola gets transformed. It remains fixed. The length of latus rectum is always 4a. This does not change because this is independent of x and y. So this is independent of the transformation of the parabola into any coordinates or in any quadrants of the xy coordinate system. So length of latus rectum remains same, though the parabola changes its transformation. Next is equation of directrix. So now that we have discussed about directrix, this is the directrix which I have here. So let's see how we can find the equation of the directrix. So as we know that for standard parabola y square equal to 4ax, the directrix is x plus a equal to 0, I have this equal to 0. But my capital X, which is x minus h, is replaced for capital X, and plus a remains same. And this is nothing but x equals h minus a is the directrix of equation 1. Very simple. Substitute for x, find small x, and equation of directrix is x equals h minus a. Next is axis of the parabola. The axis which we see here is the line which passes through the vertex and passing through focus. So in this case of transformed equation, the axis of parabola is given by the x-axis, that is y equal to 0. So using this y equal to 0, I have this as y minus k equals 0. That implies y is equal to k, where k is subtraction from y, is the axis of transformed equation 1. That's how we understand the axis. So now that we have understood the concept of identifying the focus, the vertex, the directrix, the axis or the latus rectum for a transformed equation using the original coordinates, it is very essential that we understand the original standard form of parabolas in order to indirectly understand the transformed equations of parabolas. So until unless we know the standard forms, we cannot take this so easily. So let's connect the standard forms with the transformed equations respectively for each of the types of parabolas.